J'espère que dans cette salle, il y a des hommes politiques, des femmes politiques et des gens du gouvernement. La construction hors site en France, elle est un petit peu passée sur le radar. Je vais me mettre un peu plus près. On a quand même hier eu sur notre salon hors site Monsieur le ministre Julien de Normandie qui a eu une phrase tout à fait intéressante, qui s'est montré excessivement intéressé par l'idée de la construction hors site et qui nous a dit qu'il pensait que le pays qui gagnerait le challenge de la construction industrialisée allait gagner le challenge de la construction tout court, parce que si nous n'arrivons pas à avancer sur ce domaine-là, d'autres le font. On voit aujourd'hui dans le monde entier des industriels de haut rang qui s'intéressent à la construction hors site. On peut citer l'exemple d'un Chinois qui s'appelle CIMC, qui a déjà livré 50 000 chambres d'hôtel préfabriquées en Chine et livrées dans le monde entier. Donc vous avez vu qu'en Angleterre, le gouvernement s'est fortement impliqué et engagé dans la démarche hors site depuis quelques années. Et un exemple excessivement intéressant, c'est l'exemple de ce que le gouvernement a fait sur la construction de nouvelles écoles. Ils se sont engagés dans des programmes d'accords cadres. Je crois que c'est 5 programmes en 5 ans. Le dernier programme, c'est 3 milliards de livres pour construire des écoles hors site. Et Bryan Evans, please Bryan. Thank you very much, Bryan. So Bryan, you have been in this journey to create beautiful new schools out of off-site and modular. And we have been visiting these schools with a lot of French, about I think 200 French people we bring to UK. And we have been visiting some schools. There are schools prefab, there are schools standardized. And we brought in these schools some French teachers. And they were just amazed by the quality of the teaching you can do in those schools. Just amazing. So, Bryan, can you explain the journey? Thank you very much.
But before we start, I just want to recognise that in the UK, off-site is currently being used in the custodial sector. It's being used in healthcare. It's being used for community health and local projects. Student accommodation is increasingly built off-site, and as Mark said before, there's a significant amount of housing in the UK, and that's one of Ilka's properties that he was referring to earlier. Of course, we've also now in a situation after the 3-year journey we've been on, where we have built small schools for young people, we have mid schools for the secondary schools, and we also are delivering off-site large specialist secondary schools for media and for other specialist subjects throughout the UK. The challenge has been for some time for off-site is to meet the Department for Education's design brief. It is a very high standard that's required, and the challenge has seldom been achieved in the UK. So a year ago, my 2-year appointment was further extended to work with the Department for Education to come up with an off-site solution that actually will do all of that. And thereby, the Department for Education became the first government department to actually issue a full design guide on how schools can be designed to maximise off-site. And that was the outcome, the design guide for schools. At the moment, there's a £3 billion procurement taking place using this DNA, this document in the UK. First of all, keeping the graphics really simple. This one is called Generation 5. It's one of those where they said there will be no Generation 6, but there probably will be. But the basic rules are, first of all the solutions must be safe for the children, safe for the teachers, all the visitors. Safety is an absolute essential. The second one is quite an important one. It must work as a school. We cannot let a modular solution drive the teaching environment. The modular solution must enhance the delivery of teaching and learning and in no way limit it. We must meet that brief I mentioned earlier, a very high standard, but the rule was we must meet the brief. The solution must also be sufficiently flexible to suit many different changes of site that we have in the UK. And finally, it must be affordable. It must not be more expensive than the current budget set for schools in the UK. So I introduced a process called progressive standardization, where you can achieve something, and having done that, you move on and you build on a series of standardized approaches. This came primarily from Volkswagen. They have a modular assembly toolkit. So the automotive industry, they have platforms, we have a grid. They have modules, we have clusters, and they have their toolkit, and we have our components. And it is this three-stage journey that we have been on with the Department for Education. So how did we get to our grid? Well, there's two things into here. We have £500 million worth of schools in construction off-site at the moment. So we went through all of those. We talked to the manufacturers to find out what is the most economical grid for them to manufacture. Over that, we overlaid our schedule of accommodation and came up with a series of rules, a series of areas and dimensions that would help us to arrive at a standard grid. That turned out to be a nice simple graphic, 3.6. The classroom depth is governed by the efficiency of each internal space, but the overall regularized grid became 3.6. Not just for off-site, that is now the design standard for all new schools construction in the UK and will be adopted in the next national framework for traditional sites. So, what is a cluster? Well, I'll take you through our journey. We went into each teaching and learning space and we asked 4 questions. Number 1, what is needed in that space? I'll give you an example of this shortly. The second one is, what do you need adjacent to? What do you need directly off that space? The third one, what do you need nearby to hand? And the final one is, what needs to be available within the building? Very, very simple rules for a very simple reason. And finally, I keep coming back to this, we must comply with that design brief, which is the standard. We cannot let off-site be a second-class solution. So we ended up with a series of clusters. The orange ones are the teaching clusters, the blue ones are the administration clusters, the yellow, the library, and the green are the main hall and dining areas. Now this is one of those clusters. So this is a reception, this is for 5-year-old children, and you can see there, in terms of the equipment in the space, there's the furniture, there's the interactive whiteboard, there's the storage off that space, just as examples. Next, off that space, we have supervised toilets, we have cloak spaces, and we have access externally through that indoor-outdoor play area for the children. Nearby, on this plan, you'll see there's a hygiene room in there. It is the younger people that tend to have these kind of mishaps, shall we say. So we put the hygiene room near those younger children. That's something that's nearby. And of course, finally, through the door down the corridor, we have access to dining and the hall and the other activities. And these are the principles and the rules that we used, not just for reception, not just for year 1, 2, 3, and 4, but we have applied these to all the secondary schools, modern languages, practical teaching spaces, and special educational needs. We have been very busy. So if this is our grid, what we're allowed to do, almost like a cartoon, is we can work with people and start to design the building using these clusters. Now this is a very simple, linear, straight solution, but we can get those bits of those buildings and start to work with the teachers and say, this is how a standardized school that meets that design brief, that is completely manufactured off-site, can work for you in this place. But we know for sure that behind that simple sketch are high-quality teaching spaces, teaching spaces that are properly equipped, have the right equipment and adjacencies, and that many of them are the result of years of experience and feedback from schools and trusts on how best to teach in that space. And of course, because we live in a 3D world, all this information is stored in a three-dimensional BIM model. So we can actually now go to talk to schools about their school before they even know they're going to get one. So this is information that's available. It's a solid rendered model. And all this happens in each space in every building. So we can walk through a building. And because it is simplistically clustered, we can actually use it to create a series of spaces. These are just 3 of the models that we have. We can use these clusters to create L's and T's and U's and go 3 stories and get different solutions, knowing every time that when we do these clusters that they are backed up by 3-dimensional, fully worked out plans that meet the design brief and capture all the lessons learned from the past. Whilst all that was happening, the engineering team were focusing on the environmental design, because a lot of the design brief is about the environmental performance. And from a daylighting, I've got a long time yet, I'll slow down. From an environmental design point of view, daylighting and making the most of daylighting in the space is very important. That receives a lot of attention. We went to make sure that the building wasn't overheated, and we ended up with an all-electric solution in most circumstances, where using air source heat pumps, we can provide occasional peak lopping to provide cooling in spaces that need it. But in most cases, we were able to design that need out. Energy efficiency of the building is something that's very important to us, and we provided buildings that were more energy efficient than the traditional on-site buildings. And we fully integrated building services in a modular way. So we didn't have to do extensive on-site M&E services because it was off-site. We designed the building and the M&E services so that they could be built off-site and delivered to site, in some instances pre-commissioned. I have a new word. The new word is podule, and that's the name we give to one module that is 100% fitted out off-site. For example, toilets. We are now 100% pre-commissioned off-site. Finally, one thing we also did was a whole life carbon assessment using Mott MacDonald's, our consultant, and we were able to demonstrate that we were 55% less whole life carbon than had the school been built traditionally. And within that process, there was still quite a lot of legacy calculations we had to use that weren't really off-site, but the program wouldn't change them. So we expect it to be whole life carbon a lot less than that. This has allowed us then to look at components, the standardization of the layout and the standardization of the components. If we think of manufacturing, if we think of how those cars come along that production line, and it's a simple list really. We are standardizing around 3 or 4 windows in the small school estates. We're starting to develop a school door. We're looking at standardizing the internal walls upwards. So we provide a better performing internal building, but it's easier for manufacturing and delivery in the factory itself. And it goes on, the chassis itself, the foundations, the mechanical electrical services which I've mentioned, the standardization of those, and more important, well, not more importantly, the ITT, the technology in the building, we're looking at standardizing that and actually taking all that off-site as well. So the headline that I've been using is not MMC, but for me it's designed for manufacturing assembly. We and our team have designed these buildings so that they can be manufactured off-site, somewhere 85 to 95% off-site, depending on the manufacturer's factory capabilities. But then delivered to site. So a small school will be up in 2 weeks. The main body of the building is 2 weeks to be on site. A secondary school is typically 4 to 5 weeks for the whole secondary school to go up. Now I put the word quality in here. Crawford Wright, the head of design for the Department for Education, said we must not fall back on quality. Mark mentioned it earlier. We cannot have a legacy of poor quality schools. and we have internal members within the government who are passionate about quality. And I wanted a slide specifically for that, because we will not allow schools to be a poor quality second class of buildings. And within the design guide, we put a lot of effort into explaining to the contractors what we expected to see in terms of quality. So where are we now? Well, we have a number of buildings, schools that are up and running. We have a lot of manufacturers in the UK. Now, some of those manufacturers there, nope, one of them. One of them, we took Pascal over to see one of our manufacturers in the north, who was a new start manufacturer, who by working with us has been able to grow their capabilities. This was Eco. And they've been able to expand and get investment and learn from the partnership with the DFE, and most importantly, the partnership with the other manufacturers, the ability to share lessons learned across the procurement. And that's been very successful, as you can see, a variety of contractors all delivering high quality. So what's next? How are we doing for time? I should be well short. Oh, lovely. So next, it's been mentioned already by Pascal. My next commission is to take all the work we've done with the schools and to look to produce an operational zero carbon building, but then to take that zero carbon building as an active building, a power generator, and take all those lessons learned and that standardization across the other government departments. So the work done by the Department for Education is about to be shared through the Infrastructure Projects Authority across all government departments. We enjoy having a presumption in favour of site, and we're making the most of that one. Thank you. 15 minutes.
Thank you so much, Bryan. Thank you so much.